Hello, in this module of Python programming language 9, we will discuss about list and tuple in Python. In Python list, we will try to cover list as our order. List can contain arbitrary object. List element can be accessed by index. List can be nested. List are mutable. List are dynamic. Then Python tuples with defining using tuples and tuple assignment with packaging and unpacking example. And finally conclude our session. Lists and tuples are arguably Python's most versatile, useful data type. We will find them in virtually every known trivial Python program. Here, what we will learn in this tutorial, we will cover the important characteristic of list and tuple. We will learn how to define them and how to manipulate them. When we are finished, we should have a good feel for when and how to use these object types in Python program. Python list. In short, a list is a collection of arbitrary objects, somewhat akin to an array in many other programming languages, but more flexible. Lists are defined in Python by enclosing a comma-separated sequence of objects in square brackets, as shown below. Here's the example. A is equal to this 4 bars and quirks, and print this A. So let's try to run this program in Notebook. Run this, then you can see send list star index. The important characteristic of Python list are as follows. List are order. List can contain any arbitrary object. List elements can be accessed by index. List can be nested to arbitrary depth. Lists are mutable and lists are dynamic. Each of these features are examined in more detail below. So first, list are ordered. A list is not merely a collection of objects. It is an ordered collection of objects. The order in which we specify the elements when we define a list in a characteristic of that list and is maintained for that list lifetime. Lists that have the same element in a different order are not the same. Let's try to understand this with the help of this example, like in A, 4 bars and cucks. B, bars, cucks, bar and 4. So element are same, but order are not same. So in this case, A does not equal to B, or when you type A equal to B, it gives a false result. Let's try to run this program in Notebook. So it gives a false value because value are same but order are not same. List can contain arbitrary object. A list can contain any assortment of object. The element of list can all be the same type, like A equal to 2, 4, 6 and 8. So it can print 2, 4, 6 and 8. Let's try to run this program. So 2, 4, 6 and 8. Or the element can be of varying type, like in this case float, then some string, then number, integer number, then some values are there. So let's try to run this also. That is also possible that it can contain varying types. List can even contain complex objects like function, classes and modules. Like first, A1 is integer. Let's say print A. So this is like an example of class integer. Some integer type first we define. So class integer. Then say length of A2. It is actually a keyword that are mostly used. Okay, fine. So run this built-in function len, and then just use this pass function. So pass this. So function 4 at this particular memory location. Okay, Then import path, and it will module path that is imported, built-in functions there. So now we have collect all the different kind of function, keywords, important values or important memory, the same list that is possible. So like we have just combine this, all of this, A1, A2, 4 and moeth, and it gives you the total results. So class integer like this, then second is a built-in function, this is length, then third one is a function for at this particular memory location, this is 4, and final is a import method. So this is last one is the import method. So that is possible to include variety of objects. So a list can contain any number of objects from 0 to as many as your computer's memory will allow. Like first, just a single without any argument, you just pass this. So it gives that kind of result. Nothing is there in the list. Then if you pass just one value, single value, then it gives the single element output 4. Now if you want to enter the list from 0 to 100, it provide you that particular list from 0 to 100. So whatever we given the index value of the particular whatever given the list value for the particular variable, that will be provided at the output side. A list with a single object is sometimes referred to as a singleton list. List object need not be unique. A given object can appear in list multiple times, like A for bark, bark 2 times, meow, only single time, woof, bark, bark third time, and chip. So this is not there the list are contain only single or same kind of object. It can contain multiple object or similar kind of object multiple time. Okay, so now we try to run this program. So it gives the summary. Next, list element can be accessed by index. Individual element in a list can be accessed using an index in square bracket. This is exactly analogous to accessing individual character in string. List indexing is zero based as it with a string. Considering the following list, like b is equal to 4 bar bars quacks codes. So 4 is start from 0 index, bar is started from 1, then bar second, then third quacks is third. So this is the index is for element in the that's shown in this particular figure. Here in the Python code to access some element, like first we run this program b1 with the different value. Okay, now if we run just b1 of 0, then it gives a 4 as a output. Okay, because there is 0th index. Similarly, b1 1, then it will provide bar. So this is the same example is explained. b0 4, b1 2 is bars, b1 5 is codes. 5 is codes. Virtually everything about string indexing works similarly for list. For example, a negative list index count from the end of the list. Like 0 is start from this origin point, so negative index is start from last point. So -1 is the last point. So -1, -2, -3, -4, -5. So a -1 that is equal to a 5. So let's try to run this program with a b. So b1 of say 0 1 2 3 4 5. Okay, so b1 5 run. So it is codes. Now b1 of -1, it will give you the same result code because both are same. 0 1 2 3 4 5 and -1 -2 -3 -4 -4 -6. So that is the indexing, negative indexing. Slicing also works. If a is a list, the expression am colon m returns the portion of a from index m to n, but not including index n. How it is? So let's try to understand with a particular example. Like a 4 bar, bars, conks and codes is there, then A2 to 5. So it will remove 0th index, first index, but it will provide second, third, fourth and fifth. But fifth is not included. Okay. So let's try to run this program. Like in this case, just B1 is there. So uh, B1 is given. Okay, run. Now B1 2 to 5. So in this case, the 0, 1 is not obtained or not getting output, and starting from 2, 3, 4, and also 5 is not included. So run this program. So bars, quarks and quarks is there. Other feature of string slicing work analogously for list slicing as well. Both positive and negative index can be specified. So similar way you can index with negative way, like B1 here -5. So -5 to minus, so here this type of -1. So -1, -2, -3, -4, -5. So -5 to -5, -4, -3, -2. So let's say -2. So it will include this three values: -5, -4, -3, -2 is not included. So that is negative index. You can also examine this value, that this negative index and positive index are same or not with this particular condition, like B -5 -2. Okay, I want to calculate that B1 of 2, 5, this bars, quacks and quacks are similar to -5, sorry, -1, -2, -3, -4. So I will start with -4 here, and -4, -3, -2, -1, because I want to include this quark. So -1. Now you can see, now both the values are same. So you can also check with this condition, B12 equal to so it is same because both are same. Okay, so it is true. Omitting the first index, start the slice at the beginning of the first, and omitting the second index, extend the slice to the end of the list. So this is the example, like print a first, omitting the first index. In this first case, omitting the first index and start the slice at the beginning of the list, and omitting the second index, the slice and the slice to the end of the list. So let's try to run this program. B is there, so B1 and B1. So it gives the B1 starting from first. Okay, so 0, 1, 2, 3, but 4 is not included, up to B1 0 to 4. So now 0, 1, 2, 3, 4, 0, 1, 2 and 3 index are there. Okay. Okay, so similarly you can run this kind of code, that print a starting from now second index, so up to end. So 0, 1, 2. So start from bars up to end codes, and B1 2 to length of B1. So length of B1 is what? 0, 1, 2, 3, 4, 5 is the index, and length is 6. Okay, so it's 2 from 2 to 6. That is 2 from end, 2 to end, but end part is not included. So let's try to run this program. Okay, so B2 to end. So 2, 0, 1, 2 bars, quacks, quacks. Okay, up to end. So codes is included, but in this case 2 to length of B1. So length of B is also 6. So 6 is 2, 3, 4, 5. 6 is not because and is a length. So here 6 not there. So 5, up to 5 it is a present. Okay. Then you can also add that this way, one from fourth and fourth to end from start to from fourth. So in this case what happened, that 4 bar, so we start from 0 0 1 2 3. Okay, this is the first 0 2 3, fourth are not included, and then plus fourth to end, so 0 1 2 3, fourth wax and chords is included. Okay, fine. Then whether this is true that a yes, okay, let's try to whether this is true, a b 4 of b equal to b1. I think that is not true in this case because we have changed the value, but let's try to run. Yes, it is true. B1 is what? B1 is the, yes, quacks to chords. So foo, bar, bars, quacks. Yeah, okay. So same thing is there. Yes, this value and this value both are same. Okay. Here also B1 is there. So both are same. Okay, that's why it's true condition. Okay. So we can specify a stride either positive or negative. Now let's understand how to stride. So 0 to 6 to 2. Okay, so now B1 0 to 6 to 2. So 0 1 2 with stride of 6. Okay, so 0 1 and 2 is there. Then 1 to 6 to 2. So in this case, we start from 1 to 6 to 2. So it start from bar, then 6 position, 6 quarks, and then okay, 1 2 3 4 5. Okay, so first bar, then quarks. So bars is not there because we do this slicing, and then quarks is there, and then this part is double quarks, then chords is there. Okay, this is the specific stride. We can also give as a negative stride, like 0 to negative. Okay, what it specifies is 6 to negative. Okay, so 6 0 and minus 2. That is also work possible because that. So then the syntax for reversing a list works the same way it does for string, like b1 from minus 1. So it's a reverse. Okay, so this is the reverse of this particular string. This b1 string. Okay, now with this start from 4 and end to chords. Now in the reverse, start from chords and end to 4. The colon syntax works for list. However, there is an important difference between how this operation works with a list and how it works with string. If as is a string, then as in bracket colon returns a reference to the same object, like as foobar and as this colon. So I enter this program, say foobar. Okay, now as is as means this is a part of this particular string. Okay, then if it's true, then it gives the value true. Conversely, if a list A colon returns a new object that is a copy of A, okay, so that is the difference. Now say A is equal to foo, bar, bus, wax, and chords, then A of this particular list, so it gives you the list. Now A is A, that is false. Why? Because in this case it just returns a new object that is copy of A. Okay, so this is the difference between string and list. Please remember this concept. It's very useful. Several Python operators and built-in function can also be used with the list in ways that are analogous to string. The in and not in operator, like A is, it is already run, so A is value 4 bar. Now we want to check whether quacks in A. So quacks is there, yes. so it gives a true value. So, A is already written. Okay, so if whether quack in A, yes, so it will return true. Okay. If you found third is not in A, okay, third is not in A, so that is also true. Third not in A, so that is also true. Okay. The concatenation and replication operator. This is the A value. Now A plus this growth and Garply. So it will add to the list with the help of this concatenation operator. How? Let's say A plus. So it just add 4 bar squares code, add this Galti and Garply to this particular list. If A replication, then it will replify. Okay, so now you see once again repeat all these things: far bor bar squares quirks. Then once again far bor bar quirks. The len minimum and maximum function. So len give you the length. So that is just a simple thing. Len a. So it is 6. Okay, 0. Sorry, a is here. 0, 1, 2, 3, 4, 5. Index is 5, but length is totally 6. 1, 2, 3, 4, 5, and 6. Now minimum A. Minimum A means is bar. Minimum of A is bar, and maximum is quacks. Okay, so that is a similar kind of operation. Minimum, maximum. The max is quacks. It is not an accident that string and list behave so similarly. They have both special cases of a more general object type called iterable. By the way, in each example above, the list is always assigned to a variable before an operation is performed on it. But we can operate on a list literal as well. How? Let's say far bar quacks code, and now this 2 is there. So let's write on this program first. So it gives the 0, 1, 2, the second index directly. Okay. Similarly, minus reverse case. So it gives us the reverse case directly. 4 bar quacks chords, then minus 1. So it gives the reverse directly. Okay. Okay. So quacks in this particular list, we can check with directly. Yes, it is there. So true. Then we can also concatenate the list that 4 bar bus plus quacks chords. That is nothing but this, given index in. Then length of the reverse list or same list, both are same. Length is not changed. Length is same for reverse. So for that matter, we can also do like with the string literal. Amazing with Python, and let's try to run this program. Amazing with Python. Okay, so it's just the reverse thing. Okay, so that is from this part. Now list can be nested. We have seen that an element in a list can be any sort of object that include another list. A list can contain a sublist, which in turn can contain sublists themselves, and so on to arbitrary depth. Consider this example, like A first, then its sublist BB, then its sublist CC and DDD. Now second EE and FF. Okay, then so BB EE FF is the same part. The CC DDD is a part of this BB. Then second is G, and HH and IF this particular G. Then last is J. So first just put in this example. Okay, so this is printed. Okay. The object structure that acts reference is diagram below, like A, first A. Okay, then now see, now BB. Okay, A up to that BB. then once again one space because now sublist. So CCC DDD. So once again CCC DDD. So this index is 0, this is x of 1 and this is x of 1 1. Okay, hope you understand. Then G. So G second, there is no sublist there present. Okay, G, HH and AI. So then space. Sublist there, so then HH and II. Okay, then last word is J. Okay, so J is. Okay, so this is the nested list example. So X0, X2, X0A, 2G, and X4 are string, each one character long. Okay, so if you print X0, 2 and 4, it gives the single A, G, and J. But x of 1 and x of 3 are sublist. So x of 1 is what? This. So BB, CCC, DDD, EE, and FF. This is a part of x1. Okay, BB, CCC, DDD, EE, and FFF. Then x3. So 0, 1, 2, 3. So x of 3 is HH, II. So x3 HH, II. Okay. To access the items in a sublist, simply append in an additional index. Like x of 1 is okay, x of 1 0. So x of 1 0. So x of 1 and 0. So it is BB. Okay. So x of 1 0 is BB. Okay, it's BB. Similarly, x of 1 1. So x of 1 then 1. So it is CCC DDD. Okay. See DDD. Okay. Similarly, this x12 is E, 13 is FF, x3 is HHI, and print x3 is 0, x31 is given to HH and I. X11 is yet another sublist. So adding one index access its element. Like x11 is CCC and DDD. Like in this agreement. CCC and DDD. So X110, it is CCC, and X111, it is DDD. Okay, now that is already given X110 and X111. So there is no limit short of the element extent of computer memory to the depth or complexity with which list can be nested in this way. All the usual syntax regarding indices and slicing applies to sublist as well. So this is the just example that x11 minus 1. So it's DDD and works x1 to 1 comma 3. It's CC DDD first one and 1 to 3 is EE. Sorry. So this is the similar kind of example in reverse list. So you can run this program that when you x of 3 negate minus 1, then you will receive IIH. However, be aware that operator and function applied to only the list at the level we specify and are not recursive. Consider what happened. We query the length of x using length x. Okay, so let's just first run the x. This is the x that is defined. Okay, now length of x 5. Okay. So here 1, 2, 3, 4, and 5. That is the length. Okay. Now x of 0 is A. X of 1 is this BB, CC, DDD. X of 2 is E, G. X of 3 is HH, II. And x of 4 is J. So this is the index of x of 0, 1, 2, and 4. So total length is 5. So x has only 5 elements, 3 string and 2 sublist. The individual element in the sublist don't count toward x length. So we have encountered a similar situation when using the AND IN operator. So DDD in x false. Why? Because DDD in x of 1 DDD in x of 1. DDD in x of 1, not in x. Okay. So DDD in x, that is a false. So DDD in x, write this, then it's give false. Okay. DDD in x11, yes, that is a true. So x11, that is a true. It's not part of x1, but it's part of x11. So this is not one of the element in x or x of 1. It is only directly an element in the sub list x of 1, 1. An individual element in the sublist does not count as an element of the parent list. Okay. Now next is lists are mutable. Most of the data types we have encountered so far have been atomic types. Integer or float object, for example, are primitive units that can't be further broken down. This type are immutable, meaning that they can't be changed once they have been assigned. It does not make such a sense to think of changing the value of an integer. If we want a different integer, we just assign a different one. By contrast, the string type is a composite type. Strings are reducible to smaller part, the component character. It might make sense to think of changing the character in the string, but we can't. In Python, strings are also immutable. The list is the first mutable data type we have encountered. Once a list has been created, elements can be added, deleted, shifted, and moved around at will. So Python provides a wide range of way to modify list. Okay, so modify a single list value. A single value in list can be replaced by indexing and simple assignment. Like this is the example of A. So now A0 is a full A1 bar. Okay, this is the indexing. So now if A2, here A2 is 0, 1, 2 bars, but if A2 is 10, A minus 1 matlab codes, it is 20. So that is a, sorry, done. Okay, so in this case A, if you see the A, so now see the change. A2 is 10, 0, 1, 2 is change is 10, and A minus 1, that is this value, is 20. Okay, so 4 bar 10 quacks, quacks, and 20. Strings and character data in Python that we can't do with this string. Like S is a bar pass. Then S2 is equal to X, like second. Then this is the error. Okay, so a list item can be deleted with the delete command. Okay, now once again we use the same string. First A, foo bar bars quacks quacks chores. Now delete A of 3. So 0, 1, 2, 3. So quacks is deleted. Okay, run this. Now if you print A, so quacks is deleted. Okay, modifying multiple list value. Here check single, now multiple list value. What if we want to change several contiguous element in the list at one time? Python allows this with a slice assignment, which has the following syntax: A m to n, that is equal to iterable. Again, for the moment, think of an iterable as a first. This assignment replaces the specified slice of a with iterable. Like A is equal to the same. Foo, bar, bars, quacks, quacks, curves. Then A1 to 4 is bar to quacks. Okay. 4 is not included. Okay, that's right. Now we change. 1 to 4 value is 1.1, 2.2, 3.3, 4.4, and 5.5. Now okay, so see the change. Multiple value changing in this particular list. Okay, so similarly A1 to 6 is there in this case is now changed. Now give this A1 to 6 from this particular upgraded list. If you can also change with the word bark, like 1 to 6 as a bark single value, and if you now print A, so 1 to 6 now changes the bark. Okay, so 0 is 4, then 1 to 6 is bark, and then next words. Okay, so the number of elements inserted need not be equal to the number of replaced. Python just grow and shrink the list as needed. So we can insert multiple elements in place of a single element. Just use a slice that denote only one element. Here another example, A1 to 3, A1 to 2 with 3 value, but though it is possible because mutable thing list is. So now you can see the change. First A is 1 to 3, now A is 1, then 2.1, 2.2, 2.3, and then 3. Okay, so in, not that is, this is not the same as replacing the single element with the list. Okay, now if I want to change the single elements, how it works, then at that time I have to give the index value. Like here A of 1, I want to replace 2 as a 2.1, 2.2, and 2.3. So if I want, now length is same, but now you can see the index value is changed to 2.1, 2.2, and 2.3. We can also insert an element into a list without removing anything. Simply specify a slice of the form from end to end, a zero length slice at the desired index. Like A1 to 7, 8, A2 to 2 is 3, 4, 5, 6. So now it is changed to 1, 2, 3, 4, 5, 6, 7, 8. Okay. One, 2, 3, 4, 5, 6, 7, and 8. We can delete multiple elements out of the middle of a list by assigning an appropriate slice to an empty list. We can also use the delete DL statement with the same slice, like this foo, bar, bars, quacks, packs, and curves. A 1 to 5 is blank, so now only foo, first and last, what is there between that word are just delete. Okay, so now you can see this, for example. You can also use a delete A to 5 word first statement to delete this particular, give the same result. This is the same kind of result. Either use blank or use delete. Okay, perpendicular or appending and appending item to a list. Additional item can be added to the start or end of the list using the plus concatenation operator, or the plus equal to augmented assignment operator, like A equal to foo, bar, bars, quarks, packs, codes, then A plus equal to Vaulty and Garpy. So that means that Vault and Garpy is added to this particular list. Okay, so foo, bar, bars, quarks, packs, codes, and now these two values are added to this list. We can also add this value that A foo, bar, bar, square, quads. Now A equal to 10, 20, that is added before, so equal plus A. So now this 10, 20 is added. So now new A is like this. Okay, so new A with this value adding of 10 and 20. Not that a list must be concatenated with another list. So if we want to add only one element, we need to specify it as a singleton list. This is a singleton list. Like A foo, bar, bar, square, codes, and A plus equal to 20, then it gives you error. Because I want to add this as a singleton list, but this is not specified. So integer object is not iterable, that is the error. Okay, so but just if I use this kind of statement, then you can see 20 is added. Okay, so technically it isn't quite correct to say a list must be concatenated with another list. More precisely, a list must be concatenated with an object that is iterable. Of course, lists are iterable, so it works to concatenate a list with another list. Strings are iterable also, but watch what happens when we concatenate a string onto list. So, okay, so this is the first list that we try to concatenate with a string. Actually, it works with individual words, so it is separated CORGE. Okay, code is there, but now it's concatenated CORGE. Okay, so this result is perhaps not quite what we expected. When a string is iterated through, the result is a list of its component character. In the above example, what gets concatenated onto list here the list of the character in the string codes. If we really want to add just a single string codes, so what we need to require, the earlier example, just give this index or a list value. So okay, so codes now added. If this seems mysterious, don't fret too much. We will learn about this in iterable things. Then method that modify a list. Finally, Python supplies several built-in methods that can be used to modify a list. Information on this method is detailed below. The string method did not modify the target string directly. That is because strings are immutable. Instead, string method return a new string object that is modified as a directed by method. They leave the original target string unchanged. As foobar, then s.upper, and print. So now this is foobar is now changed to uppercase. So foobar to foobar. So okay, first print s, then t. So this is the s, then t is a change with the upper. So all the case are in all the printed case uppercase. So list method are different because lists are mutable. The list method show here modify the target list in the place like a dot append in bracket object append an object to a list. A dot append object object name to the end of the list. So how it actually works, that's right to example understood with the help of example. A is equal to a and b. A dot append 1 2 3. Okay, so this with the help of this value is added or appended in this particular list. Okay, so a b now append 1 2 3, but this method modify the target list in place. They do not return a new list. Actually they change the list. Okay, so x a b a append 1 2 3 print x. In this case it is none. Why none? a dot append x equal to a dot append 1 2 3 print x, it provides none. And when you print a, then it is ab 1 2 3. Okay, so a value is changed to ab 1 2 3. There is not any kind of like matrix are there in a x, sorry, that's why it gives a none result. Okay, understood? Remember that when the plus operator is used to concatenate to a list, if the target operand is an iterable, then its elements are broken out and appended to the list individually. Okay, so how it is there? So this a1b a plus e1 2 3, so that is iterable, so that's broken out and append out to the list as an individual. Okay, so okay, so a b and this is separate out 1 2 3. The dot append method does not work that way. If an iterable is appended to the list with dot append, it is added as a single object. How it is there? Like a dot append 1 2 3. Now it is added as a single object. Okay, so a1 1b ab, then a dot append as a single object. Now 1 2 3. So AB 1, 2, 3. Thus, with dot append, we can append the string as a single entity. Okay, so A, once again example with this is foo, AB, A dot append foo, A. So in this case, foo has enter the list as a single entity, AB. Okay, so A, B and foo. A dot extend, iterable. Extend a list with the object from iterable. Yes, this is probably what we think it is dot extend. Also add to the end of a list, but the argument is expected to be iterable. The item in iterable are added individually. How it is there? Like A is equal to AB, A dot extend 1, 2, 3, and A. So now let's check what happened at the output. In this case, 1, 2, 3 is extended in the given list of A. Okay, so in the way when we have like the plus operator, more precisely, since it modified the list in a place, it behaves like the plus equal to operator. Okay, so plus equal to operator seem work as an extend. Now A dot insert in bracket index object, insert an object into a list. So A dot insert in bracket index object, insert object into list at the specified index. Following the method call, a index is an object and the remaining list elements are pushed to the right. So how actually this work? That first try to understand with the help of example. A equal to foo bar bars quarks quarks and codes and A dot insert 3 comma 3.14159. So what is the value of A of 3? So A of 3 is now 3, this value 3.119. Okay, so let's try to run this program. So this is the value of A, and now if you want to check the A, so now 0, 1, 2, 3. Okay, so third index is changed to this 3.14159. A removed object, remove an object from the list. A remove object from the list if object isn't in A, an exception is raised. Like A foo bar bars quarks quarks codes, A dot remove bars and A. So in this case, bars is removed from this particular list. Okay, so bars is removed from this particular list. If you want to remove bark that is not there in this particular list, then we'll give you the error. Okay, error is there because that is not listing and that is not present in this particular list. Now if dot pop index equal to -1, so remove an element from the list. This method different from remove in two ways. We specify the index of the item to remove rather than the object itself. The method returns a value, the item that was removed. So now what happened? A dot pop simply remove the last item, this last item in the list. So A foo bar bars quarks quarks and codes, A dot pop then execute, then codes is removed. So codes is removed. So now what is value of A? Foo bar bars quarks and quarks. Okay, so similarly, once again, if you run this program A dot pop, then last element in this list is quarks. So that is once again removed. So when you once again A, so now C. Okay, so that is the effect of this pop. In the optional index parameter specified, the item at the index is removed and returned. Index may be negative as with the string and list indexing, like A pop 1. So 4 and bar. So this is the first bar is removed. So when you see A, so now bar is removed from this particular A list. Okay, as well as -3, A pop -3. Okay, -3, -1, -2, -3. Now this quarks is removed. So let's run this program. So okay, so quarks is removed. Okay, so index default to -1. So A dot pop is -1 is equal to A dot pop. So index is last element is -1. So index is -1. So last element is removed by default. Lists are dynamic. This tutorial began with the list of 6 defining characteristics of Python list. The last one is that lists are dynamic. We have seen many examples of this in this section above. When items are added to a list, it grows as indent, like a, foo, bar, bars, quirks, and curves. A 2 to 2 is equal to 1, 2, 3. Then a plus equal to 3.14159. So what happened? First 0, 1, 2 as it is. Now 2, 2, 2 is 1, 2, 3. So now it is changed index of value of index 2 bars at 1, 2, 3. Then it is in fact is also lastly 3.14159. So it is added to 3.14159. Okay, so this is the example. Similarly, a list string to accommodate the removal of item. Our 2 to 3 is blank, so 0, 1 bars and quirks is 0, so that is removed. Okay, let's try to run this program so you can understand easily. Okay, so foo bar 1, 2, 3 bars. 2 to 2, this 2 is 2 to 2, this 2 is not included, so you want to bars is added, then quirks, codes, and lastly 3.14159. And then a foo bar bars quirks and codes, then say bar quirks and codes. So now 2 to 3, so 2 second element bars is gone. Okay, and delete a of 0, so foo is also gone from this particular list of a. Now next task, tuple. Python provides another type, that is an ordered collection of objects called tuple. Pronunciation vary depending on whom we ask. Some pronounce it as true as it were spelled topple, rhyming with the mod the hopple, and others the it was spelled tuple, rhyming with supple. So my inclination is the latter one, since it is presumably derives from the same origin as quintuple, octuple, and so on. And everyone I know pronounce these letters though they rhyme with a supple. So defining the using the tuples. Tuples are identical to list in all respect except for the following parameter. Tuples are defined by the enclosing the elements in the parentheses instead of square bracket. Tuples are immutable. Okay, this is one of the important things. Tuples are immutable. So here is a short example showing the tuple definition, indexing, and slicing. So T is equal to foo, bar, bars, quirks, and codes. So when you run this program, then so okay, so it is the now T of 0. So T of 0 is foo, T of 1 is 0 foo. Similarly, T of -1 is codes. -1 is codes. So indexing same. 1, 2, 2, then tuple. Okay, so 1, 2, 2. Okay, 1, 2. Sorry, 1, 2, 2. 2. So 0 is not there. Bar, bars, and curves. 0, 1, 2. Okay, fine. So 1 is index. 1 is there. Never fear, for every string and this reversal mechanism works also for tuple, like T reversal. So this is now change codes, first bar, and so. Even though tuples are defined using parentheses, we still index and slice tuple using the square bracket, just as for string and list. Just remember this thing. Everything we have learned about lists, they are ordered. They can maintain arbitrary object. They can be indexed and slide. They can be nested. It's true of tuple as well, but they can't be modified. Like Tifu bar bars. Now I want to add, as we already did in bar. That is not happen in this tuple. It gives you error. Okay, this is the error. So tuple object does not support item assignment. Why use a tuple instead of a list? So program execution is a faster when manipulating a tuple than it is for the equivalent list. This is probably not going to be noticeable when the list or tuple is small. Sometimes we don't want the data to be modified if the values in the collection are meant to remain constant for the life of the program. Using a tuple instead of a list guards against accidental modification. There is another Python data type that we call dictionary, which require as one of its component a value that is of an immutable type. A tuple can be used for this purpose, whereas a list can't be. In this session, we can display the value of several objects simultaneously by entering them directly at the prompt separated by commas, like A foo, B 42. So A 3.14159 and B. So this is definitely understand that this is a tuple. Okay, so this is a type as tuple. Python displays a response in parentheses because it is implicitly interpreting the input as a tuple. There is a one peculiarity regarding the tuple definition that we should be aware of. There is no ambiguity when defining any empty tuple, nor one with the two or more elements. Python knows where we are defining a tuple. Like t is equal to t is 0. So this is a tuple. When we define with parentheses, it's a type t, then it is tuple. Okay. T12 type tuple. Okay. So 1, 2, 3, 4, 5 type 2 tuple. But what happened when we try to define tuple with the only one item? Let's try to run this program. Only one item. Okay. So it gives the integer. Okay. So since parentheses are also used to define operator precedence expression, Python evaluated the expression to as simply as the integer and created integer object. To tell Python that we really want to define a singleton tuple, include a trailing comma just before the closing parenthesis. So t 2 comma, then it gives a tuple. Now t of 0 is 2 and t of minus is also 2. So you probably need to define singleton tuple often, but there has to be way. When we display singleton tuple, Python include the comma to remind we that it is a tuple. Okay, so it is a tuple thing. Now tuple assignment, packing and unpacking. As we've already seen above, in a literal tuple containing several items can be assigned to a single object. T is equal to foo, bar, bars and quarks. When this occurs, it is and though the items in the tuple have been packed into the object. Like this T is equal to foo, bar, bars and quarks. So foo is there, bar is there in the tuple, bars is there and quarks is there. Tuple packing. So T, foo, bar, bars and quarks. Okay. Now T of 0 is foo, T of minus 1 is a quarks. If that packed object is subsequently assigned to a new tuple, the individual items are unpacked into the object in the tuple, like S1, S2, S3 and S4. So quarks, bars, bar and foo now unpacked to the new tuple. So S1 is S2, S3, S4 equal to T. Then S1 is 4. Okay. So now, sorry, what happened? 1, 2, 3, 4. Okay. S1, S2, S3, S4 equal to T. There is not an error. Let's take a last S1, S2, S3, S4 equal to 2. Okay, just remove this line. Okay, oh yes, yes. I think we should forget to this line. Now, S1, S2, S3, comma T is equal to T. So what T is? Okay, that's why there. Because last time we run this program as a T is 2, that's why you cannot understand 2 with a 4 bar. Okay, so let's try T equal to is now it is okay. Now let's see what T. Okay, now that's done. So when we run this program now, that's correct. Okay, so now it is run. Okay, so now if you put S1, so S1 is 4. So S1 is 4. S2 is bar. Okay. So same way S3 bar and S4 is quarks. When unpacking, the number of variable on the left must match the number of value in the tuple. I have already seen this kind of error earlier. Okay, because in T only 2 comma is only one single element is there, but whereas in S1, S2, S4 there is a 4 value is there, so it gives the error. So packing and unpacking can be combined into one statement to make a compound assignment like this way. S1, S2, S3, S4 run, so S1 is equal to 4. S2 is equal to bar, S3 is equal to bar, and S4 is equal to box. Again, the number of elements in the tuple on the left of the assignment must equal to the number of the right. If you have only just added S5, then it provides you the error, because in left it is 4, 5 and 4, so 5 does not equal to 4, so it gives the error. In assignment like this, in a small handful of the situation, Python allows the parentheses that are usually used for denoting a tuple to be left out. So T is equal to 1, 2, 3. Then T is 1, 2, 3. Okay, so T is 1, 2, 3. Now x1, x2, x3 is equal to T. That is okay, no problem, because T also 1, 2, 3. So that is no problem with this statement. Now x1, x2, x3 is 1, 2, 3. Okay. Now x1, x2, x3. First x1, x2 type on this program. Okay. So x1, x2, x3 is 1, 2, 3. Now I want to change value. x1, x2, x3 is equal to 4, 5, 6. Okay. So now it is changed. So now x1, x2, x3 is 4, 5, 6. Okay. Now it is changed. Now t equal to 2, then T is equal to 2, then it is, and in the case it is an integer, but I have to add this comma for tuple. So T tuple. Okay. So it works the same whether the parentheses are included or not. So if we have any doubt as to whether they are needed, go ahead and include them. In this case, we have not included the parentheses. Tuple assignment allow for a curious bit of idiomatic Python. Frequently, when programming, we have two variables whose values we need to swap. In most Python programming language, it is necessary to store one of the value in the temporary variable, while the swap occurs like this, like a is equal to foo, b is equal to bar, then a comma bar, then a is equal first a equal to foo, b is equal to bar, a comma bar is foo bar. Now I want to swap variable value of a and b. So in this case, I require temporary variable. We need to define temporary variable to accomplish the swap. Temp is equal to a equal to b, b equal to temp, then ab. So in this case, now bar and foo are swap. Okay, so now you can see bar and foo are swap with the help of this temp variable. In Python, the swap can be done with a single tuple assignment also. How? So A4, B bar, AB is equal to 4 bar. Now magic. B is equal, AB is equal to BA. Okay, okay. First I want to run this program. Okay, sorry. Now just AB equal to BA. Because I just copy from this. BA. So now you can see AB is equal to 4 and bar and 4. Okay, with this single this line we can swap the value. So as anyone who has ever had to swap value using a temporary variable knows, being able to do it in this Python but where we have explained, it will never get better than this. Okay, so now we conclude the session that this tutorial cover the basic property of Python list and tuples and how to manipulate them. We will use this extensively in our Python programming. One of the chief characteristics of list is that it is ordered. The order of the state element in a list is an interesting property of that list and does not change unless the list itself is modified. The same is true of tuples, except of course they can't be modified. This is the reference realpython.com. Thank you.